Today's preparation is about economic life. So typically the longer that you keep an asset like a tractor, a car, a bus, whatever you have, piece of machinery, the lower the amortized cost of its initial purchase, the equivalent uniform annual cost of its initial purchase. The higher the maintenance cost, though. If you buy that car and you keep it for 20 years, in that 20th year, you're going to be paying probably some pretty high cost for replacing things like the transmission or the engine. That's when the big problems start to set in. So it's great if you keep it longer because the initial purchase cost feels a little bit more comfortable, but the maintenance costs keep growing. So how long should you keep the asset? At what point should you cut your losses and go ahead and buy a new one? So here's the key idea. Retire the asset at the point of minimum equivalent uniform annual cost. You take the initial purchase cost into account, you take the maintenance costs into account, you take all the costs associated with into account, you calculate the EUAC, assuming that you were to retire it or let go of it and buy a new in year 1. You do the same thing for year 2, you do it for year 3, and you calculate all that out, and for each year that you could retire it, potentially, you're going to end up with a different equivalent uniform annual cost. And it makes sense then that you'd want to retire it and actually get the new one when you find the year that has the minimum value for the equivalent uniform annual cost. This is called the economic life of the asset, the length of time, the time at which there's the minimum equivalent uniform annual cost. So let's do an example. Buses in a municipal transit system cost $120,000. Their maintenance costs and salvage values are in the table below. So here you can see that initial cost of $120,000. In year 1, the maintenance costs are reasonable and you can salvage it for a high price, for a high amount. As you go through time, the maintenance costs get higher and the salvage values get lower. So while you're tempted to keep it for a long time because you want to distribute this purchase over a long period of time, you're going to have to replace it when you're done with it, right? So, on the other hand, you're going to start paying more for maintenance and you're going to get less for salvaging the piece of equipment. So you want to find at year 1, what would be the equivalent uniform annual cost if I retired it now? So another example, if the bus is retired in year 3, you pay the maintenance cost for years 1, 2, and 3. You don't get the salvage value for retiring it in year 1 because you didn't retire it in year 1. You don't retire it in year 2 either. You only get the salvage value for the time that you actually retire it. So when you're computing the equivalent uniform annual cost, you take into account that initial amount, any of the maintenance costs you'd pay through the year that you retire it, but you only get your salvage value for the year that you retire it in. So you calculate those equivalent uniform annual costs and you find which year corresponds with the lowest cost, and that's the economic life. So when should the city replace its buses if money can be borrowed at an interest rate of 8%? And that's another way of saying that the interest rate in this problem is 8%. Because if you think about it, the city borrowing money versus making money, their debt increases at a rate of 8% per year. So that's still an appropriate number, and we can still do engineering economics in the same way. So let's create a table as usual. Time 0, 1. The initial purchase costs $120. Let's keep the numbers positive. Actually, we're talking about costs here. So 120,000, 0 for all the rest of them. The maintenance costs are 0 initially. You don't have to pay maintenance as soon as you drive it off the lot. 35,000, 38,000. The salvage value that you'll get, we'll make these negative because they're negative costs. Okay, so how do we calculate the EUAC for each year? Well, first we need to calculate the total as usual, and then we're going to calculate a discount factor. We'll compute the net present value, and then we're going to compute the equivalent uniform annual cost from that present value. We're going to actually have to have two different discount factors. We're going to have the discount factor that we take this future value and turn it into a present value. So this is the P given F. And this here that converts between the net present value and the EUAC, well, the discount factor is going to depend what year we retire it in. So we're going to have an A given P. There, we'll look that up when the time comes. So the total here, we need to be careful when we're computing this, right? Because the net present value, we are going to want to consider the net present value of the purchase and all the maintenance costs up to the year that we retire it. But we're only going to want to consider the salvage value from the year that we retire it, not the previous years. So we're going to have to actually be a little bit careful. So what I'm going to do is I'm going to split. I'm actually going to calculate the net present value of everything, or let's say the net present cost. I'm going to move this discount factor over to here. We're going to compute the net present cost of the purchase and maintenance, and separately from the salvage cost. So the present value of the salvage. Okay, it'll make more sense as we go through. So let's total the cash flow for the year, the purchase and maintenance costs. We have the P over F factor. Let's get our interest rate in here. Interest rate is 8%. This is 1 plus the interest rate to the negative year. And the net present cost, oops, as always, net present cost is the discount factor times the total. That's the present cost for the year. So I'll call it present cost 1. We'll call this present cost 2. Present cost 1 includes everything but the salvage, and present cost 2 is going to only include the salvage value. Let's move this discount factor over to here. All right, now let's calculate the present cost of the salvage value. So multiply the salvage times the P over F discount factor. Okay. Now we can actually calculate. We've got the present value of the purchase cost and the maintenance separate from the salvage cost. And the reason we've done that is because when we're calculating the net present cost, what we want to do, let's say we're in this year, right? We want to take the sum over all of the costs from each year, the present costs for each year when we're calculating that. But we only want to take the salvage value from the year that we're retiring it in. Right? We can't include all these. We didn't salvage it in those years, so we don't get those. We do include all of these because we did incur all these maintenance costs, and we did incur the initial purchase costs. So that's why we've separated this out and calculated separately the net present values of the purchase and maintenance in this case, and the salvage value. We've calculated them separately so we can sum them separately. Now, the general idea is that you're going to separate out any costs that you're going to incur regardless of what year that you retire in, and from the ones that you're going to incur only for retiring in a particular year. You're going to separate those and come up with the right formula to come up with the appropriate net present cost, assuming that you retire in that given year. Now, this formula, I could type in the same sort of thing for every year, right? If I retire in year 4, then I want to sum up all of these and add the retirement cost for that, or the salvage value for that year. We learned a trick yesterday in discussion when we were trying to find actually the break-even time, is if you lock F3, right, this initial cell, the first cell that it's going to start, and F8 we leave variable, this one here we've left variable, then what we can do is if we locked that initial one, we can drag this back up. We can drag this up and you see that it's kept F3 in its place, and we're summing through a row that changes. We've also left H6, this one, we've let that float with us as well. So the formula is valid for all these years. So here is our net present cost for these different years. Now, the net present cost only seems to grow, right? Because your maintenance costs increase and your salvage values diminish. So the net present cost is getting bigger and bigger. But we need to turn it into an equivalent uniform annual cost. We're going to amortize it over the duration of time. So we need to calculate this A over P factor. And to do that, we look at our handbook and we find the factor that gives us the annual cost given P, and it's this formula. So let's see, I'm going to take a screenshot of that just so I remember. All right. So let's implement that properly. It's going to be the interest rate. So let's do our fancy go into formulas, and we're going to define names corresponding with the variables. I'll define the name I means this cell, and I want to also define the name N, and it's going to refer to, well, this cell, but I want to lock the, I don't want to lock it because as I want to lock maybe the column, so A, but I don't want to lock the row because as I drag, I want to drag the formula down and I want it to follow me, which one it refers to, so I'll say okay. So now I can type in I, and oops, I have to say equals I, and it'll give me 8%. If I say equals N, it gives me 0. If I say equals I and I drag it down, it's referring always to 8%. If I say equals N and I drag it down, it gives me the year number. Okay, so let's multiply I times 1 plus I to the N, and we take all that and we divide by 1 plus I to the N minus 1. Division by 0 in that case, but it's good for all the rest of them. I think I'm just going to delete this. We're not going to calculate equivalent uniform annual cost for here. Let's just not even calculate that because you're not going to retire it as soon as you buy it. That doesn't make any sense to purchase and retire. So the formulas don't work for that, and that's okay. So now we just need to multiply the net present cost by the A over P factor, the discount factor. And there we go. And we find which one of these is the minimum. Well, this is 104,000. Let's maybe make this a little bit easier to see. It gives us the commas there to separate the points. So 104,000 no, 71,165. So it looks like the economic life is going to be 3 years based on the fact that this has the lowest, if you retire in year 3, then the equivalent uniform annual cost is going to be the lowest out of all the options.